Have you ever stepped outside on a perfectly quiet night, feeling the solid, unyielding earth beneath your feet, and wondered how we can feel so completely still while hurtling through the infinite dark of the cosmos? The universe is endless motion, a gentle yet ancient dance of unimaginable proportions. Yet here we stand, wrapped in a comforting illusion of stillness. We perceive our world as vast, our oceans as boundless, our human history as a long and ancient tapestry. We measure our brief lives in years and decades, feeling a profound sense of permanence in the mountains that rise above us and the valleys that stretch below. But what happens to our fragile understanding of reality when we are suddenly confronted with a scale that our mind simply cannot hold? What happens when the quiet journey of discovery leads us to something so massive, so incomprehensibly huge, that even the brightest stars we see in our night sky seem like nothing more than floating dust motes lost within the vast empty halls of a cosmic cathedral? To truly understand the mystery of the universe, we must first learn to let go of our familiar earthly anchors. We must allow ourselves to drift into the absolute silence of space, where the true scale of creation reveals itself not in sudden flashes of insight, but in slow, majestic, and deeply humbling revelations. The cosmos is not merely a physical space out there. It is a profound mirror reflecting our deep need for connection with something far greater than our everyday concerns. We are explorers seeking a gentle truth hidden in the dark. At this moment in our journey, I want to take a gentle pause. Welcome to Theodore, the researcher. It is a wonderful mystery that 71% of the curious explorers who watch our quiet journeys into the cosmos have not yet subscribed to the channel. If you find peace and wonder in these cosmic explorations, please consider subscribing. It helps us tremendously to continue creating these meditative spaces for you, and it ensures we can keep traveling together through the endless wonders of the universe. Now, let us return to the quiet dark of the cosmos. Let us begin this contemplation with our home, the Milky Way. When you gaze up from a dark, secluded place, far away from the glaring and artificial lights of our modern cities, you might see a hazy, glowing river stretching majestically across the heavens. Ancient people looked at this very same gentle glow and saw mythic stories written in the sky. The ancient Greeks believed it was literally spilled milk from a goddess, while others across different cultures saw it as a luminous spiritual path for souls on their final journey into the afterlife. For most of human history, that beautiful, milky band of light was universally thought to be the entirety of the universe. We firmly believed our local cosmic neighborhood was the whole of existence, a safe, enclosed, and deeply human-centric realm. But the truth, as science has so beautifully and rigorously revealed over the centuries, is far more humbling and far more vast. Our Milky Way is what astronomers refer to as a barred spiral galaxy, a magnificent and ancient pinwheel of stars, gas, and primordial dust, swirling gracefully around a central bulge where an enormous black hole quietly sits in the dark. From one edge of our galactic home to the other, the distance is roughly 100,000 light years. Please stop for a moment and let that number gently sink into your mind. Light, the absolute fastest traveler in the cosmos, moving at speeds that defy common sense, would take 100,000 years just to cross from one side of our galaxy to the opposite edge. 100,000 years is a span of time that stretches far beyond the dawn of modern human civilization. It is much longer than the time since our distant ancestors first learned to paint their dreams on the rough walls of hidden caves. It encompasses the rise and fall of every empire, every forgotten generation, every quiet triumph, and every silent tragedy of the entire human experience. And yet, that vast, staggering expanse is merely the width of our own tiny, local neighborhood in the cosmos. Within this immense spiral structure, there are somewhere between 200 billion and 400 billion stars. Try to visualize a number that breathtakingly large. It is not just an abstract statistic printed in a textbook. It is a collection of hundreds of billions of individual suns, many of which burn with a quiet, steady light remarkably similar to our own. Around those countless stars orbit an unimaginable number of planets, moons dancing gracefully in the dark, and ancient comets leaving trails of frozen ice across the void. Our own sun, a lonely but steadfast star, sits about 26,000 light-years away from the galactic center, nestled peacefully in a quiet cosmic neighborhood known as the Orion Arm. Even moving at a staggering speed of roughly 500,000 miles per hour, our solar system takes about 250 million years to complete just one single orbit around the center of the Milky Way. Astronomers sometimes call this incredibly long period a cosmic year. During the last time our planet was in this exact location in the galaxy, the dominant forms of life on Earth were simple, primitive creatures navigating the ancient oceans long before the dinosaurs ever took their first heavy steps upon the land. That is how overwhelmingly vast even our own galaxy truly is. The spaces between these stars are almost unimaginably empty, filled with a profound silence that stretches for unbroken light years. Our closest stellar neighbor, a dim and modest red dwarf known as Proxima Centauri, sits about 4.24 light-years away from us. If you were to shrink our mighty sun down to the size of a single grain of sand, Proxima Centauri would be another tiny grain of sand resting roughly 4 miles away, with absolutely nothing but the deepest void between them. This emptiness is extraordinarily hard for us to wrap our minds around. We are so deeply accustomed to living on a crowded planet, surrounded by billions of other people, constantly sharing space with countless other living, breathing things. We are used to density, to things being reassuringly close together, to the physical world feeling full and substantial. But the moment you step outside the protective boundary of our solar system, profound emptiness becomes the universal rule. Stars are separated by such vast, incomprehensible gulfs that the chance of any two of them colliding by pure accident is essentially zero. Entire galaxies can pass through each other without any stars actually hitting one another, performing a ghost-like dance orchestrated solely by gravity. Yet somehow, even in all that infinite emptiness, there is enough scattered material out there to make hundreds of billions of stars in our galaxy alone. For centuries, humanity remained comfortably unaware of the true, terrifying, and beautiful scale of this cosmic ocean. But the invention of the telescope, that humble human tool made of shaped glass and metal, changed our relationship with the universe forever. As early astronomers peered deeper into the heavens, those hazy patches of milky light resolved into millions of individual distant stars. And then, in the early 1920s, an astronomer named Edwin Hubble made a discovery that profoundly shattered our illusion of cosmic isolation. Looking through what was then the largest telescope in the world, positioned at the Mount Wilson Observatory, he meticulously observed a class of pulsating stars within the Andromeda Nebula. By calculating their true distance, he realized that Andromeda was not a mere cloud of gas contained within our own galaxy. It was roughly 2 million light-years away, It was an entirely separate island universe, a staggering distance beyond the edges of the Milky Way. Suddenly, our galaxy was no longer the entirety of existence. It was merely one single galaxy drifting in a much larger ocean. Today, our most advanced observations estimate that there are around 2 trillion galaxies in the observable universe. 2 trillion. That is a 2 followed by 12 zeros, a number so astronomically large that it breaks the delicate boundaries of human comprehension. Each one of those 2 trillion galaxies contains billions, and sometimes trillions, of its own stars. The universe is a magnificent tapestry, woven from ancient light and persistent gravity, stretching across billions of light-years of space and deep time. But among these 2 trillion galaxies, we must realize that they are not all created equal. Some are tiny, quiet dwarf galaxies harboring only a few billion stars, floating like tiny islands in the dark. Others are majestic, sprawling spirals like our own Milky Way or Andromeda. And then, lurking in the deepest, most distant corners of the expanding universe, there are the true cosmic monsters. These are the giant elliptical galaxies, colossal entities that have grown over billions of years to proportions that defy reason and peacefully challenge our sanity. And one of them, the largest we have ever managed to discover in the dark, sits patiently at the heart of a distant cluster, quietly ruling over its gravitational domain. This galaxy, known by the deceptively unassuming catalog name of IC1101, is a structure so vast that it makes our Milky Way look like a mere speck of insignificant dust floating in a giant, empty warehouse. It is a stunning monument to the relentless forces of gravity and time, a profound testament to what the universe can build when given billions of years to patiently mold matter in the dark. To begin to understand this giant, we must let go of everything we thought we knew about size and scale. We must prepare our minds for a journey into the extreme, where the sheer numbers stop being cold mathematics and become pure, relaxing poetry. Let us pause and deeply breathe in the magnitude of this realization. We are incredibly small, yes. Our planet is a tiny rock circling an average star in a quiet arm of an ordinary galaxy. But the very fact that we possess the conscious capacity to look out into the endless dark, to measure the distance to objects billions of light-years away, and to comprehend the existence of a galaxy like IC1101 is nothing short of a cosmic miracle. We are the universe experiencing itself, conscious atoms forged in ancient stellar fires that have somehow awakened to gaze back at the very stars that birthed them in the beginning. Our curiosity is the most profound force we possess, a gentle light that illuminates the darkest corners of the unknown. As we continue this contemplative journey, we will delve deeper into the heart of this colossal galaxy, unraveling the quiet mystery of its immense and infinite nature. When we speak of distances like 1 billion light-years, we are not merely talking about physical space. We are engaging in a deep conversation with time itself. The light that finally reaches our fragile telescopes from the distant reaches of the cosmos is profoundly ancient. It has been traveling continuously across the cold, silent void for eons. If you could miraculously travel at the exact speed of light, tracing the flawless path of a single ancient photon from the burning surface of a star in IC1101 all the way to the glass lens of a telescope here on Earth, you would experience a relentless journey lasting over 1 billion years. Imagine that single photon of light. It was emitted in the fiery heart of a distant sun, long before the continents on our own planet had even begun to settle into their current, familiar shapes. It traveled bravely through the hazy, gas-filled atmosphere of its home galaxy, escaping the relentless gravitational pull of billions of other stars, and launched itself into the ultimate intergalactic void. For hundreds of millions of years, it flew silently through absolute nothingness, a quiet messenger carrying the fundamental story of its origin. While this ancient light was crossing the dark abyss, entire complex species rose and fell on our distant Earth. Majestic mountains were violently thrust up from the crust and then slowly worn down by patient wind and rain over countless millennia. The great dinosaurs walked the Earth, ruled for millions of years, and then vanished forever, all while this tiny packet of light was still endlessly falling toward us through the dark. By the time that light finally reached our world, quietly hitting the delicate mirror of a space telescope, humanity had evolved from the dust, built grand civilizations, learned to mathematically map the stars, and developed the sophisticated technology required to capture that extremely faint glimmer. This is the true meditative beauty of astronomy. Every time we look deep into space, we are looking deep into the past, acting as cosmic archaeologists, gently brushing away the dust of time. We find absolute peace in the fact that the universe is so vast, so old, and so gentle in its grand progression. This journey of understanding is an infinite path, a quiet exploration that heals the mind and soothes the soul as we confront the endless mysteries of the cosmos. Have you ever imagined what happens when two island universes, each containing billions of stars, crash into one another? We humans often associate the word collision with sudden destruction, with noise, and with violent chaos. We think of twisting metal and deafening sound. But the cosmos operates on a scale that transforms our concept of violence into a slow, silent, and deeply gentle ballet. When giant galaxies interact, there is no sound. There is only a profound and infinite silence. The spaces between stars are so unimaginably vast that when two galaxies pass through each other, the stars almost never actually touch. Instead, they perform a majestic, ancient dance choreographed solely by the invisible hand of gravity. It is a quiet journey that unfolds over hundreds of millions of years, a process that is less a collision and more a slow merging of cosmic oceans. This is the secret to how the largest structures in our universe are born. They do not suddenly appear. They accumulate patiently and quietly through eons of cosmic time. This concept, known as hierarchical structure formation, is a fundamental pillar of our modern understanding of the universe. It tells us that the cosmos builds things from the bottom up, starting incredibly small and growing unimaginably large through countless patient mergers over the deepest stretches of time. As we continue to drift through these ancient mysteries, I want to take a brief moment to welcome you back to Theodore, the researcher. It remains a quiet mystery that 71% of you who join us on these relaxing journeys through the cosmos have not yet subscribed to the channel. If these stories bring you peace and a deeper connection to the universe, please consider subscribing. It gently supports our work and ensures we can continue exploring this infinite wonder together. Now, let us return to this silent dance of the galaxies. The giant we are contemplating, known as IC 1101, did not begin its life as the colossal monster we observe today. Roughly 13 billion years ago, not long after the primordial dawn of the universe, the cosmos was a very different place. It was filled with vast, formless clouds of hydrogen and helium gas, drifting quietly in the dark. As the gentle but relentless force of gravity began to pull the slightly denser regions of this gas together, the very first stars ignited. These early stars clumped together to form the first primitive galaxies, which were small, irregular, and chaotic. In the region of space that would eventually become the home of IC 1101, countless small galaxies were born close to one another in a particularly dense node of the cosmic web. Over the next several billion years, these small island universes began to feel the irresistible gravitational pull of their neighbors. They drifted toward each other, drawn into a slow, inevitable embrace. When they met, their delicate spiral structures were gracefully unwound and destroyed by gravitational tides, mixing all their ancient stars together into a new, larger, and more chaotic shape. This is what astronomers call galactic cannibalism, a term that sounds violent, but actually describes a process of profound and quiet unification. Scientists estimate that this magnificent giant has undergone at least 76 major mergers over its long history. 76 times, another substantial galaxy fell slowly into this cosmic giant and was peacefully absorbed. Countless smaller dwarf galaxies have also been gently consumed over the eons, their stars added to the vast, expanding halo of the giant. As these countless mergers unfolded, they left behind a beautiful, featureless expanse. When you look at a spiral galaxy like our own Milky Way, you see defined arms, a flat rotating disk, and regions where new stars are actively being born. But IC 1101 is an elliptical galaxy. It possesses no spiral arms, no flat disk, and very little active star formation. The violence of billions of years of gravitational interactions has completely erased any original structure it might have had, stirring its trillions of stars like grains of sand in a cosmic bowl. What remains is a smooth, glowing oval, a massive testament to billions of years of quiet accumulation. It is estimated to stretch somewhere between 4 million and 6 million light-years across. This makes it roughly 40 to 60 times larger than our entire Milky Way galaxy. If you were to somehow place IC 1101 where our galaxy currently resides, it would not merely swallow our sun and our stars, it would engulf our entire local group of galaxies. Andromeda, situated 2 million light-years away, would find itself entirely swallowed within the borders of this behemoth. The Triangulum Galaxy, the Magellanic Clouds, and dozens of other neighbors would all become tiny, insignificant components of this singular entity. Yet, despite containing an estimated 100 trillion stars, this colossal structure is actually a dying galaxy. To understand this beautiful paradox, we must look at the lifeblood of cosmic creation, gas and dust. In the universe, stars are born from massive, cold clouds of molecular gas that collapse under their own weight. Whenever two galaxies merge, the gas within them gets compressed, often triggering an enormous and sudden burst of star formation. For billions of years, as IC 1101 consumed its neighbors, it also consumed their gas, sparking brilliant eras of stellar birth. But eventually, the raw materials ran out. The mergers heated the remaining gas to extreme temperatures, making it expand and escape the galaxy's gravitational grasp, or they compressed it so rapidly that all available gas was turned into stars in brief, intense flashes. Today, the stars within IC 1101 are almost exclusively old, ancient stars that burn with a cool, red glow. Most of them are what astronomers call red giants or long-lived red dwarfs, stellar objects that have been shining steadily for billions of years and will continue to do so for trillions more. There are almost no new blue stars being born in this quiet giant. It is a galaxy existing in a state of majestic twilight, a vast retirement community for ancient stars that have survived the chaotic history of the cosmos. It is an empire that has conquered everything in its path, but has no new generations to carry its legacy forward. And sitting at the exact center of this fading empire is something even more mysterious and impossible to fully comprehend. Hidden within the core of IC 1101 lies one of the most massive single objects ever discovered in the entire universe. Every large galaxy contains a supermassive black hole at its center. Our own Milky Way has one named Sagittarius A star, which contains roughly 4 million times the mass of our Sun. The black hole at the center of the Andromeda Galaxy is considerably larger, containing perhaps 100 million to 200 million solar masses. But these numbers pale into insignificance when compared to the monster lurking in the dark heart of IC 1101. Scientists estimate that the supermassive black hole at the center of this giant galaxy contains somewhere between 40 billion and 100 billion times the mass of our Sun. Let us pause and allow that staggering figure to wash over us. 50 billion solar masses, all compressed into an infinitely small point in space. It is a concept that utterly breaks the limits of human intuition. The boundary of a black hole, the point of no return, where the gravitational pull becomes so intense that not even light can escape, is called the event horizon. For a black hole containing 50 billion solar masses, this boundary would be unimaginably vast. It would have a radius of roughly 150 billion kilometers. To put that completely incomprehensible distance into a perspective we can almost understand, consider our own solar system. From our warm Sun all the way out to the cold, distant orbit of Neptune, the entire solar system is about 9 billion kilometers across. The event horizon of the black hole inside IC 1101 is roughly 16 times larger than our entire solar system. If you were to place this dark giant where our Sun currently sits, its absolute darkness would swallow Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and reach far beyond the frozen realm of Pluto, plunging everything we have ever known into a space where time and physics, as we understand them, completely break down. Yet, despite its terrifying size and its unimaginable power, this supermassive black hole is currently resting in silence. It is not actively devouring huge amounts of matter. There is no brilliant, blinding accretion disk swirling furiously around it. Like the galaxy that surrounds it, the black hole is waiting in the dark. It has already consumed most of the material that was easily within its gravitational reach. This profound quietness is deeply related to the lack of new star formation. Without free gas falling toward the center, the black hole has almost nothing to eat. Have you ever listened closely to the profound silence that follows a great storm, feeling the residual energy still lingering in the quiet air? Though the supermassive black hole at the center of IC 1101 currently sleeps in the dark, it was not always this peaceful. There are still magnificent, ancient traces of its past activity echoing through the cosmos. Astronomers looking deeply into this region of space have detected a bright radio source sitting exactly at the galaxy's center, quietly catalogued as PKS 508 plus 059. This faint radio emission is a ghostly whisper from the past, coming from relativistic jets of material that were blasted outward from the immediate vicinity of the black hole at nearly the speed of light. These jets were historically powered by the black hole's immense rotation and its unimaginably strong magnetic fields. As these powerful streams of particles shot out into the deep void, they carved out enormous cavities in the surrounding superheated gas. When scientists look at this galaxy using advanced X-ray telescopes, these massive cavities become clearly visible. They appear as beautiful, dark bubbles of very hot and extremely thin gas, blown outward by the incomprehensible energy released near the event horizon millions of years ago. Some of these silent, glowing bubbles are millions of light years across, serving as a lasting testimony to ancient periods when the black hole was far more active and ravenous than it is today. The sheer amount of energy required to inflate just one of these colossal bubbles is staggering, equivalent to the total energy output of billions of ordinary stars burning for millions of years. Before we journey further into these cosmic storms, I would like to gently pause and welcome you back to Theodore, the researcher. It remains a quiet mystery that 71% of the curious souls who join us on these relaxing explorations have not yet subscribed to our channel. If you find comfort and wonder in the infinite silence of space, please consider subscribing. It gently supports our cosmic journey and ensures we can continue to explore these beautiful mysteries together. Now, let us drift back into the ancient history of this majestic giant. This beautiful interplay between supermassive black holes and their host galaxies is one of the profound mysteries in astrophysics. Scientists believe that these monsters play a crucial role in regulating how galaxies grow and evolve. When vast clouds of gas flow toward the center, the black hole begins to feed, releasing enough energy to heat the surrounding gas and push it outward. This process acts exactly like a cosmic thermostat, preventing the gas from cooling and collapsing into new stars, ultimately helping to determine the final size of the galaxy itself. In the case of IC 1101, this intricate feedback loop is partly responsible for the galaxy's current, peaceful state. Over billions of years, the black hole helped shut down the birth of new stars by heating the intergalactic gas, creating a sublime equilibrium. But how does a black hole grow to become 50 billion times more massive than our Sun? The answer lies in the same process of galactic cannibalism that built the galaxy itself. Black holes grow by slowly consuming the matter that falls past their event horizons. When two galaxies inevitably collide and merge in the dark, the supermassive black holes sitting at their respective centers eventually find each other and merge as well. Over the course of IC 1101's long and magnificent history of consuming other galaxies, its central black hole has been fed again and again. Every single time IC 1101 consumed another galaxy, it also captured and absorbed that galaxy's central black hole. Every ancient merger brought in more stellar fuel for the black hole's historically insatiable appetite. The process by which two supermassive black holes merge is incomprehensibly violent, though it happens in absolute silence. When two galaxies first collide, their central black holes do not immediately meet. They are initially separated by vast, dark distances and are surrounded by billions of swirling stars. But as the galactic merger patiently progresses over millions of years, the gravitational friction with the surrounding stars causes the two black holes to slowly spiral toward the center of the newly combined galaxy. Eventually, these two monsters get close enough to form a binary system, locking into a beautifully terrifying orbit around one another. As they continue to orbit, they begin to lose precious energy through the emission of gravitational waves. These waves are literal ripples in the very fabric of space-time itself, stretching and squeezing the physical universe as they pass through it at the speed of light. As these invisible waves carry energy away into the deep void, the orbit between the two black holes begins to inevitably shrink. They spiral closer and closer, orbiting faster and faster in the dark, until finally they merge together in a catastrophic, invisible event that releases enormous amounts of pure energy. When two supermassive black holes finally combine, the final merger releases more total energy than all the individual stars in a typical galaxy combined, mostly in the form of gravitational waves. We humans have only very recently developed the sensitive technology required to actually detect these silent ripples passing through our tiny world. The first direct detection of this cosmic phenomenon came in the year 2015, when the LIGO Observatory successfully measured the gentle waves from two smaller stellar mass black holes merging about 1 billion light-years away from Earth. Since that miraculous moment of discovery, dozens of these gravitational wave events have been quietly observed, opening up an entirely new and profoundly different way for us to study the hidden universe. Future detectors, like the planned LISA mission that will one day fly quietly in the vacuum of space, will be specifically designed to detect the massive mergers of supermassive black holes. When this new instrument finally launches, perhaps in the 1930s, it might actually detect events that are incredibly similar to the ancient mergers that built up the central black hole of IC 1101. We will literally be able to listen to the silent universe as giant black holes collide, adding a completely new sense to our astronomical toolkit. The black hole hidden within IC 1101 has patiently experienced dozens of these massive mergers over its long, dark history. Each single merger added more mass to the growing monster and fundamentally altered the black hole's cosmic spin. The complex process of experiencing multiple, repeated mergers also profoundly affected the surrounding galaxy. As the binary black holes spiraled toward their inevitable union, their combined gravitational influence interacted violently with stars passing nearby. Through complex gravitational interactions, the merging black holes essentially flung millions of stars outward, violently ejecting them from the galaxy's center. This phenomenon is precisely why the physical core of IC 1101 is so incredibly large, yet remains relatively faint compared to its massive size. Repeated black hole mergers have systematically scattered stars away from the very center over billions of years, creating a core profile that is deeply unusual for galaxies of this magnificent magnitude. In fact, an exquisite study conducted in the year 2017, using detailed images from the Hubble Space Telescope, carefully measured this galactic core and found that it stretches across nearly 14,000 light-years of space. This means that just the central core of IC 1101, not the entirety of the majestic galaxy, but merely its innermost region, is physically larger than most entire dwarf galaxies existing in the cosmos. This core alone quietly holds more stars than most complete galaxies scattered throughout the universe. The presence of such an enormous scoured core raises deeply fascinating questions about the intimate connection between giant galaxies and the dark monsters residing at their hearts. Scientists have patiently discovered that there is a profound relationship between the total mass of a galaxy's central black hole and the physical properties of the galaxy itself. Bigger galaxies almost always tend to have bigger black holes. Did the primordial black holes form first in the dark and then slowly grow their protective galaxies around them? Or did the massive galaxies form first from the primordial gas and then patiently build up their black holes over countless eons? The most beautiful answer seems to be that they grew together in a slow cosmic waltz. Each one intimately influenced the development of the other over billions of years of deep time. As IC 1101 steadily consumed more and more of its neighboring galaxies, its central black hole simultaneously consumed the black holes from those very same victims. These two parallel processes continuously fed into each other, creating a magnificent feedback loop that ultimately produced both the largest known elliptical galaxy and one of the largest known black holes in all of existence. Let us embark on a gentle thought experiment together to help our minds touch the edges of this infinity. Imagine, if you will, that you could somehow magically travel from one outer edge of IC 1101 directly to the other side. You would need to cross a terrifyingly empty expanse of somewhere between 4 million and 6 million light years. Remember that a single ray of light travels at an incomprehensible speed of about 6 trillion miles in just one single year. Even moving at that maximum possible velocity, crossing the entirety of IC 1101 would still take you millions of years of continuous, unbroken travel. Let us gently try another, perhaps more grounded comparison to feel the weight of this scale. Consider the Voyager 1 spacecraft, a tiny, fragile mechanical explorer launched by NASA in the year 1977. It is currently the fastest human-made object that has ever managed to leave the familiar bounds of our solar system, silently traveling through the dark at a speed of roughly 38,000 miles per hour relative to our Sun. At that incredible speed, the Voyager 1 probe would take about 80,000 years just to cross the relatively tiny void and reach the nearest star to our Sun, Proxima Centauri, which sits only about 4 light years away. If we were to ask this same brave spacecraft to cross the entire width of our own Milky Way galaxy, moving at its current maximum speed, the journey would patiently take about 2 billion years to complete, and to successfully cross the staggering width of IC 1101, our fastest spacecraft would need somewhere between 80 billion and 120 billion years of continuous flight. That span of time is substantially more than the entire universe has even existed since the Big Bang. Even armed with our greatest, fastest technological achievements, simply crossing this single, solitary galaxy would be a completely impossible task. It forces us to sit in quiet awe of the vastness that surrounds our fragile world. Have you ever tried to hold an impossibly large idea in your mind, feeling your imagination stretch until it gently touches the absolute limits of human thought? Let us try another beautiful way to visualize the quiet, staggering enormity of the space we inhabit. If you could miraculously shrink our entire Milky Way galaxy with all of its hundreds of billions of stars, its sprawling spiral arms, and the cozy neighborhood where we make our home, down to the modest size of a standard dinner plate measuring roughly 10 inches across, IC 1101 would be the size of a very large swimming pool. Our entire galaxy, containing every single star you have ever seen in the night sky, every planet we have ever discovered, and every historical event humanity has ever recorded, would be reduced to nothing more than a tiny, fragile dish floating aimlessly in a vast, deep sea. Or consider the quiet, ancient journey of light itself. The faint light from IC 1101 has traveled for over 1 billion years through the cold, silent dark just to reach our fragile eyes. In all that incomprehensible time, brilliant light has been continuously streaming away from this giant galaxy in every possible direction. Every single second of every single day for over 1 billion years, IC 1101 has radiated enough light to travel approximately 186,000 miles into the void. Over 1 billion years, that light has traveled 1 billion light years, which is mathematically equivalent to about 6 billion trillion miles. And these ancient photons, these tiny, tireless messengers, are only now just arriving at the delicate mirrors of our telescopes. They are ancient ghosts that left their colossal home galaxy when our own planet Earth was still in its earliest primordial stages of complex life. Before we follow these ancient photons any further into the dark, I want to take a gentle pause. Welcome back to Theodore, the researcher. It is a quiet mystery that 71% of the fellow cosmic explorers who join us on these relaxing journeys through the universe have not yet subscribed to the channel. If you find deep peace and a sense of wonder in these contemplative cosmic stories, please consider subscribing. It gently helps us continue to create these meditative spaces for you, ensuring that our shared journey of discovery never has to end. Now, let us return to the quiet miracles of human ingenuity and the ancient stars. The profound discovery and the subsequent meticulous study of IC 1101 would simply not have been possible without tremendous, deeply human advances in telescope technology. The ability to understand these cosmic monsters is a beautiful testament to our relentless desire to know the universe. In the very early, quiet days of astronomy, telescopes were severely limited by the physical size of their handcrafted glass lenses and mirrors. Larger telescopes could gather more faint light and slowly reveal fainter objects hidden in the dark. But there were practical, earthly limits to how big you could physically make a telescope on the ground. The Earth's atmosphere also posed a constant, shimmering problem. Our atmosphere, while absolutely essential for breathing and sustaining our fragile lives, is constantly moving, heating, and shimmering, which is exactly why the distant stars appear to gently twinkle in the night sky. This poetic twinkling, while beautiful to the naked eye, drastically blurs the images that ground-based telescopes can capture, severely limiting how clearly astronomers can see truly distant objects. For most of the 20th century, astronomers could only barely see that IC 1101 existed and that it was very large, but they could not study its intricate, detailed structure through the shifting haze of our skies. Everything profoundly changed with the majestic launch of the Hubble Space Telescope in the year 1990. Floating peacefully in the cold vacuum of space, high above the shimmering distortions of the atmosphere, Hubble could suddenly capture images with an incredible, breathtaking clarity that no human had ever seen before. Over the quiet decades since its launch, Hubble has observed IC 1101 multiple times, peeling back the layers of mystery and revealing intricate details about its massive core, its surrounding ghostly halo of ancient stars, and its complex gravitational relationship to the hundreds of other galaxies trapped within its surrounding cluster. More recently, curious astronomers have utilized a magnificent variety of other telescopes to study this giant at completely different wavelengths of invisible light. Advanced radio telescopes have silently detected the ghostly emission from its mostly dormant central black hole. Powerful X-ray telescopes have beautifully observed the superheated, invisible gas that fills the immense cluster all around it. Highly sensitive infrared telescopes have successfully peered straight through the obscuring cosmic dust to study the ancient stellar populations hidden deep within the galaxy itself. Each new observation, each patient gathering of ancient light, gently adds to our growing understanding of this cosmic giant. But you might peacefully wonder, how do we actually know that it is a billion light years away? How do we accurately measure distances in a space so vast that we cannot ever hope to cross it? Distance is one of the most fundamental and crucial quantities in all of astronomy, but it is also inherently one of the absolute hardest things to measure in the dark. How do you tell exactly how far away a glowing point of light is when you cannot travel there and stretch out a physical measuring tape? For relatively nearby stars, astronomers use a beautiful geometric technique called parallax. As our Earth quietly orbits the Sun each year, our visual perspective on nearby stars changes ever so slightly against the deep background of much more distant stars. By carefully measuring how much a star appears to visually shift over the course of a year, astronomers can mathematically calculate how far away it truly is. But for significantly more distant objects, this tiny parallax shift becomes far too minuscule to measure, even with our most remarkably precise instruments. For these extreme cosmic distances, astronomers are forced to rely on a brilliant concept known as the cosmic distance ladder. One vital rung of this cosmic ladder involves a very special type of star called a Cepheid variable. These magnificent stars physically pulsate in brightness in a highly regular, predictable pattern, and the specific period of their pulsation is directly related to their true, intrinsic luminosity. Cepheids can be seen in galaxies located tens of millions of light years away. But IC 1101 is so unimaginably distant that even this brilliant technique fails. For such truly extreme distances, astronomers must patiently rely on even brighter standard candles scattered in the dark. One of the most important of these is a catastrophic type of exploding star called a type Ia supernova. Because the strict physical conditions for this massive detonation are nearly identical from one supernova to another, they all reach roughly the exact same peak brightness. By measuring exactly how bright a type Ia supernova appears when it flashes in the dark, astronomers can accurately estimate how far away its host galaxy is drifting. Another profoundly beautiful technique involves measuring what is known as the redshift of a galaxy's ancient light. As the very fabric of the universe continuously expands, the light traveling from distant objects gets physically stretched to longer and longer wavelengths. This stretching literally shifts the color of the light toward the red end of the visual spectrum, hence the poetic name redshift. By carefully measuring the specific redshift of the faint light arriving from IC 1101, astronomers have determined with remarkable precision that it is located approximately 1.04 billion light-years away from us. There is a deeply contemplative aspect to all of this that we must gently embrace. When we look at IC 1101 through our telescopes, we are absolutely not seeing the galaxy as it exists today. We are literally seeing it precisely as it was over 1 billion years ago, at the exact moment when the light we detect today first began its long, silent journey toward Earth. 1 billion years ago, our own Earth was a profoundly different and alien place. Complex, breathing animal life had not yet evolved in the oceans. The entire planet was quietly populated only by single-celled organisms, and perhaps the very simplest of multicellular life. The massive continents were in completely different positions, slowly gathered together in strange configurations. During all the immense time since then, the light from IC 1101 has been tirelessly traveling through the silent vacuum of space. It crossed the vast, terrifying emptiness between galaxies, occasionally passing like a ghost through thin clouds of intergalactic gas. It traveled at the absolute fastest speed anything can possibly travel in our physical universe. Yet the sheer distance was so immense that it took over 1 billion years to finally arrive here. This means the IC 1101 we see resting in our telescopes might be very different from the IC 1101 as it actually exists right now. Over 1 billion years, so much could have quietly changed in the dark. Ancient stars that were brightly shining then might have completely burned out by now, leaving only cold remnants behind. We have absolutely no way of knowing what IC 1101 truly looks like at this exact moment in time. In a very real and profoundly beautiful sense, astronomers are the ultimate archaeologists of the cosmos, forever studying the distant past rather than the immediate present. Every single observation of a distant cosmic object is a literal look back in time, a precious glimpse of how things used to be rather than how they are now. This inevitable time delay gracefully allows us to study cosmic history directly. By observing these ghostly echoes, we find a deep, enduring peace in the infinite mysteries of the dark. Have you ever walked along a quiet, empty beach at twilight, picked up a single handful of dry sand, and gently tried to count the individual grains slipping softly through your fingers? Our human minds are beautifully adapted for the small, immediate, and intimate world around us. We are built to count the passing of local seasons, the physical steps we take on a familiar earthly path, and the rhythmic, comforting beats of our own fragile hearts. But nothing in our evolutionary history has ever truly prepared us to mentally hold the sheer infinite numbers that govern the vast and ancient cosmos. When we speak of a galaxy like IC 1101, we are casually tossing around numbers that completely shatter our everyday reality and demand a profound shift in our perspective. Let us try to gently bridge that impossible gap with a few quiet thought experiments, allowing our minds to slowly stretch into the dark and find peace in the staggering immensity of creation. Imagine that you wanted to take a simple photograph of every single star in this magnificent giant. Suppose you had a magical, incredibly fast camera that could snap exactly one flawless picture every single second, and you possessed infinite endurance, never needing to pause for rest, food, or sleep. To photograph all 100 trillion stars, one by one, your quiet photographic journey would take you over 3 million years of continuous, unbroken effort. If you had started taking these pictures at the exact moment the very first primitive humans began to walk upright on the ancient, sun-baked plains of Earth, you would still have millions of years of photography ahead of you tonight. Or consider the literal sands of our world. If you were to gather every single grain of sand from every single beach, every sprawling desert, and every hidden ocean floor on our entire planet Earth, you would hold a number perhaps in the hundreds of trillions. IC 1101 contains roughly as many burning, active stars as there are individual grains of sand on our entire world. Each one of those stars is a massive nuclear furnace, silently burning ancient hydrogen into helium, pouring energy out into the infinite void. Each one has a deep history, a quiet present, and a mysterious future unfolding in the dark. Before we walk further into this cosmic sea of sand, I want to gently pause and welcome you to our quiet community here at Theodore, the researcher. It is a persistent and beautiful mystery that 71% of the curious explorers who regularly join us on these relaxing journeys through the universe have not yet formally subscribed to the channel. If you find peace, comfort, and a deep sense of wonder in these contemplative cosmic stories, please consider subscribing today. It gently helps us continue to create these meditative spaces for you, ensuring that our shared journey of discovery never has to end. Now let us return to the impossible scale of our giant galaxy and the quiet paths that wind through its ancient stars. Imagine for a moment trying to physically walk across the breathtaking expanse of IC 101. The average human walking speed on a gentle, flat path is about 3 miles per hour. If there were a magical solid bridge stretching completely across the vast diameter of this elliptical giant, and you were to walk along it 24 hours a day without ever stopping to rest your weary feet, the journey would take you approximately 50 trillion years to walk from one edge of the galaxy to the opposite side. Please, let the sheer weight of that span of time settle peacefully into your mind. 50 trillion years is over 3,000 times longer than the current known age of the entire universe. You could quietly walk for the entire history of everything that has ever happened, from the explosive dawn of the Big Bang right up until this very moment, and you would have covered less than 1/13,000th of the total distance across this single, solitary galaxy. We are tiny travelers standing on the shore of a cosmic ocean that is so wide it renders the very concept of physical travel essentially meaningless. Even the speed of light itself is humbled by this magnitude. A message carried by light from a civilization on one far edge of IC 1101 would take between 4 million and 6 million years to quietly reach a listener on the opposite edge. If they immediately replied, the answer would take another 4 to 6 million years to return. A single, simple conversation consisting of a hello and a reply would span geological epochs, outlasting the entire existence of countless species on a habitable world. Communication across a single galaxy would literally span the deep time of the cosmos itself. This staggering vastness naturally brings a profound, lingering question to our curious minds. If this galaxy is so impossibly enormous, containing 100 trillion ancient stars, could it be a bustling home to intelligent alien life? Could there be minds out there in the deep dark, quietly looking back at the cosmos just as we are doing tonight? This is the kind of beautiful mystery that our current science cannot directly answer. We barely possess the delicate technology to search for microbial life beneath the frozen ice of moons in our own solar system, let alone across a billion light years of empty, silent space. But we can gently contemplate what the mathematics of the cosmos softly suggest to us. If life fundamentally requires solid planets to take root, and planets naturally form in the swirling dust surrounding newborn stars, then a galaxy with substantially more stars should theoretically harbor significantly more potential homes for life to emerge. Our own Milky Way is currently estimated to hold somewhere between 100 billion and 400 billion planets. If even a tiny microscopic fraction of those distant worlds are blessed with the right conditions for liquid water and stable temperatures, there could be millions of living worlds hidden in our local cosmic neighborhood alone. Now, gently scale that hopeful logic up to the incomprehensible magnitude of IT 1101. With 100 trillion burning stars, this dying giant could comfortably possess hundreds of trillions of distinct planets orbiting in the silent dark. Even if the spark of life is exceedingly rare, even if only 1 in a billion of those distant planets ever developed the simplest, single-celled organisms in some warm, primordial ocean, that would still result in hundreds of thousands of living worlds scattered throughout the galaxy's vast halo. And if only 1 in a trillion of those worlds saw evolution eventually yield intelligent beings capable of building complex civilizations, pondering the stars and weaving their own cosmic stories, there would be 100 separate, distinct civilizations currently existing within IC 1101. Of course, we must humbly acknowledge that these numbers are purely philosophical estimates based on fragile assumptions we cannot yet verify. We do not actually know how common life truly is in the vast universe. We do not know the precise, miraculous alchemy that transforms dead chemistry into breathing biology. We do not even know for absolute certain that life strictly requires rocky planets like ours, or that it demands liquid water, or that it must be based on carbon atoms. The sheer, infinite diversity of physical conditions in the cosmos might be beautifully matched by an equal diversity of forms that life can possibly take. What we can comfortably say, however, is that IC 1101 offers an unimaginably enormous canvas for whatever mysterious cosmic processes might eventually lead to the miracle of life. This massive galaxy has been continuously manufacturing stars and forging heavy elements for billions of years. The crucial carbon, the vital oxygen, and the heavy iron that living things desperately require have been baked inside stellar cores and scattered violently through ancient supernovas countless times across its vast expanse. If intelligent, curious beings do exist somewhere within the borders of IC 1101, what might they experience when they step outside on a quiet evening and look up at their own night sky? Their view of the infinite cosmos would be profoundly, breathtakingly different from ours. Here on Earth, we look up and see a relatively sparse field of distinct twinkling stars, with a gentle, hazy band of the Milky Way stretching quietly across the heavens. But the physical density of stars within a giant elliptical galaxy, like IC 1101, is significantly higher than in the flat, rotating disk of a spiral galaxy like ours. If a habitable planet were located anywhere near the bustling center of this colossal giant, the night sky would be absolutely ablaze with perpetual, stunning light. Ancient stars would crowd so closely together in the visible heavens that there might not be any experience of true, deep darkness at all. The combined, overlapping glow of billions upon billions of nearby suns would fill their sky with a perpetual, golden twilight that would completely outshine the rest of the universe. Human concepts like navigating the dark oceans by identifying distinct constellations would be utterly impossible for them, because there would simply be far too many stars to distinguish one familiar pattern from another. They would be permanently lost in a breathtaking sea of eternal starlight, a beautiful cage of brilliance. Further out toward the thinning edges of the galaxy, the visual conditions might be slightly more akin to what we experience on Earth, but it would still remain a profoundly alien sky. There would be no sweeping spiral arms tracing majestic patterns across the dark void. There would be no distinct central band of milky light marking the flat plane of a galactic disk. Instead, the ancient stars would be evenly distributed in a massive, spherical pattern, gently surrounding any planetary observer in a uniform, glowing shell of stellar light. We must quietly wonder, would such isolated beings ever know about the chaotic, violent history of their massive home? Would their astronomers have cleverly deduced that their peaceful, featureless sky was actually built from the shattered remains of dozens of smaller galaxies violently consumed over billions of years? Would they have detected the terrifying, dormant monster sitting at the exact center of their galaxy, or figured out that their universe was already billions of years old and slowly fading into a permanent cosmic twilight? We cannot possibly know the answers to these quiet questions, but it is deeply, profoundly comforting to simply imagine that somewhere out there, hidden in the incomprehensible vastness of IC 1101, on just one of those hundreds of trillions of possible planets, intelligent beings might be sitting quietly under their brilliant sky, asking the exact same existential questions about the universe that we ask here on our fragile Earth. They might be looking out into the deep intergalactic void, seeing other distant galaxy clusters as tiny, faint smudges of light, and softly wondering if those distant realms contain other curious minds. They might even have built a telescope powerful enough to detect the faint light of our own Milky Way, though from their unimaginably distant perspective, our magnificent home would appear as nothing more than another unremarkable, tiny spiral galaxy drifting quietly among billions of others. The universe is incredibly vast beyond all human comprehension, and the infinite possibilities it patiently contains are equally vast. Every single galaxy we take the time to study gently reminds us of this infinite vastness and challenges us to rethink our humble place within it. Have you ever stood in the middle of a vast open landscape, surrounded by towering mountains or an endless flat horizon, and felt a profound sense of isolation, only to slowly realize that the gentle wind brushing against your skin intimately connects you to the entire breathing planet? We often think of space as a realm of total separation, a cold void where distinct objects float in absolute, lonely darkness. But the deeper we look into the quiet mysteries of the cosmos, the more we understand that nothing, absolutely nothing, exists in true isolation. Even the colossal giant we know as IC 1101, a galaxy so unimaginably massive that it challenges the very limits of our comprehension, is not wandering alone in the dark. It sits majestically at the beating heart of a much larger, incredibly ancient structure known to our astronomers as the Abel 2029 galaxy cluster. To truly understand the origin, the life, and the quiet destiny of the largest galaxy we have ever discovered, we must first gently widen our perspective to take in the awe-inspiring environment that surrounds and nurtures it. A galaxy cluster is one of the most magnificent and incomprehensibly large gravitationally bound structures in the entire universe. It is a cosmic city of light, a vast congregation that can comfortably contain hundreds, or even thousands, of individual island universes, all locked together in an ancient, endless orbital dance around a common, invisible center of mass. Before we drift further into the hot, invisible oceans of this cosmic city, I want to take a gentle pause. Welcome, once again, to Theodore, the researcher. It remains a beautiful and quiet mystery to me that 71% of the curious souls who regularly join us on these relaxing journeys into the profound depths of the universe have not yet officially subscribed to our channel. If you find peace, comfort, and a deep sense of expanding wonder in these contemplative stories, please take a brief moment to consider subscribing. It gently helps us continue to create these meditative spaces for you, ensuring that our shared journey of cosmic discovery never has to end. Now let us return to the deep, silent architecture that holds the ancient universe together. The staggering space between the individual galaxies within the Abel 2029 cluster is not an empty, dead vacuum. It is actually filled with an incredibly vast, almost invisible ocean of extremely hot gas. Astronomers poetically refer to this as the intra-cluster medium. This gas has been violently heated over billions of years by the sheer, relentless gravitational energy released as the entire cluster slowly pulled itself together from the primordial void. It burns at terrifying temperatures reaching tens of millions of degrees, hot enough to completely incinerate any ordinary matter we know on Earth. Yet, this gas is so profoundly diffuse so incredibly thin by our terrestrial standards that if you could magically scoop up a cubic meter of this space, you would find only a tiny handful of solitary atoms drifting through the dark, because there is so much of this sparse gas spread out over millions of light years of empty space. It collectively adds up to an enormous amount of physical mass. Because it is so intensely hot, it emits highly energetic X-rays, which are completely invisible to our fragile human eyes but glow brilliantly when observed by advanced space telescopes like the Chandra X-ray Observatory. When we carefully map this invisible ocean, we see that it is densely concentrated around IC 1101, forming a glowing, superheated atmosphere that extends for millions of light years into the silent intergalactic void. This superheated atmosphere is not just a passive background. It is an active, dynamic participant in the quiet life of the giant galaxy it surrounds. Normally, such incredibly hot gas would slowly radiate its energy away in the form of X-rays, gradually cooling down over hundreds of millions of years. As it cools, it should theoretically condense and fall like a gentle cosmic rain into the massive galaxy sitting at the center of the cluster. In many galaxy clusters across the universe, this process, known as a cooling flow, continuously delivers hundreds of solar masses of fresh, life-giving gas into the central galaxy every single year, sparking brilliant and chaotic new eras of stellar birth. But in the quiet, aging heart of IC 1101, something profound and mysterious is intentionally interrupting this cosmic rain. The ancient, supermassive black hole hiding in the dark center of the galaxy is acting exactly like a master cosmic thermostat. Whenever the surrounding gas begins to cool and fall toward the event horizon, the black hole awakens just enough to consume a tiny portion of it. This quiet feeding process instantly releases a tremendous burst of pure energy, which then heats the surrounding gas and forcefully pushes it back out into the deep void, physically preventing the vast majority of it from ever cooling enough to form new stars. We can actually see the physical evidence of this majestic feedback loop written in the hot gas itself. The advanced X-ray images reveal enormous, dark cavities, gigantic bubbles of relatively empty space that have been violently carved out of the intracluster medium by the immense, invisible jets of energy released by the central black hole. These dark bubbles are millions of light years across, serving as silent, enduring monuments to the delicate balance of power between the largest black hole we have ever found and the vast ocean of gas that surrounds it. This intricate, self-regulating mechanism is the primary reason why IC 1101 is no longer birthing new suns. The black hole and the galaxy are locked in a quiet, eternal equilibrium, a stable relationship that has been gently shaped over billions of years of shared evolution. But to truly grasp the scale of this equilibrium, we must also acknowledge the invisible ghost that secretly governs this entire cosmic city. Everything we have discussed so far, the hundreds of trillions of burning stars, the massive, superheated clouds of X-ray emitting gas, the central black hole with its 50 billion solar masses, all of it combined, accounts for only a tiny, almost insignificant fraction of the total mass actually present within the Abel 2029 cluster. The vast majority of the gravitational force holding this enormous structure together comes from something we simply cannot see, something that fundamentally refuses to interact with light in any way. This is the profound mystery of dark matter. It is a substance so elusive that it passes right through our most sensitive earthly detectors without leaving a single trace. Yet it is so overwhelmingly abundant that it single-handedly dictates the architecture of the entire universe. In a massive cluster like Abel 2029, dark matter provides the essential gravitational scaffolding, the invisible framework that safely cradles the galaxies and the hot gas, keeping them from simply flying apart into the expanding void. Scientists patiently estimate that if we include this vast invisible halo of dark matter, the total mass of the IC 1101 system could be as high as 1,100 trillion times the mass of our own sun. It is an ocean of invisible mass that extends tens of millions of light years into the dark, a silent ghost that fundamentally shapes the reality of everything we can see. The enduring existence of dark matter is a beautiful and deeply humbling reminder of the strict limitations of our current human knowledge. We can carefully measure the light of 100 trillion ancient stars. We can perfectly map the complex cavities in the superheated gas, but the most dominant physical substance in the universe remains completely hidden from our eyes. It gently forces us to approach the cosmos with a deep sense of humility, realizing that we are only just beginning to scratch the surface of the infinite mystery. Let us close our eyes and take a quiet, mental journey back in time, tracing the long history of this invisible architecture. About 13 billion years ago, long before the Earth was even a thought in the cosmic mind, the universe was a featureless, expanding fog of simple hydrogen and helium gas, interlaced with vast, invisible threads of dark matter. These threads formed a complex, three-dimensional web that stretched across the entirety of existence. Where these invisible filaments intersected, gravity began to pull the ordinary gas together, forming the very first stars and the first chaotic proto-galaxies, the region of space that would eventually become Abel 2029, was located exactly at one of these massive, dense intersections of the cosmic web. Countless small galaxies were born here in the dark, and they immediately began interacting with one another. Because the universe was smaller and much more compact in its youth, mergers between these early galaxies happened with incredible frequency. The ancestor of IC 1101 was likely born from the violent merging of several of these early proto-galaxies. Over the ensuing billions of years, as it sat securely at the very bottom of the cluster's deepening gravitational well, it experienced merger after merger, slowly growing from a modest collection of a few billion stars into the colossal, featureless giant we observe today. As we patiently contemplate this slow 13 billion year process of hierarchical assembly, we begin to touch upon the deepest and most profound question of all. How is it that a universe composed of cold, dark matter, expanding empty space, and ancient, unthinking nuclear fires can eventually give rise to beings capable of wondering about its origins? The very atoms that currently make up your brain, the complex molecules that are right now processing these very words and experiencing this gentle sense of wonder, are the exact same types of atoms that were forged in the hearts of the ancient stars scattered across the Abel 2029 cluster. The iron in your blood, the calcium in your bones, the carbon in your DNA, they were all manufactured in the fiery deaths of primordial suns. We are not merely observers standing on the outside of the universe looking in. We are a fundamental, intrinsic part of the cosmos itself. We are the universe experiencing itself. The slow, silent evolution of the cosmos over 13 billion years was not just a process of building larger and larger galaxies. It was a process of steadily building complexity, of organizing dead matter into structures capable of supporting chemistry, biology, and ultimately, conscious thought. When we look deeply at IC 1101, we are not just looking at a massive collection of ancient stars. We are looking at a magnificent monument to the exact same physical forces and processes that, in our own tiny, quiet corner of the Milky Way, eventually gave birth to consciousness. The true wonder is not just that the universe is so vast, but that within this vast, dark silence, the universe has somehow awakened. It has developed eyes to see its own ancient light, minds to comprehend its own impossible scale, and hearts to feel a deep, abiding peace in the presence of its infinite mystery. Have you ever stood on a quiet shore at twilight, watching a distant ship slowly sail away over the curved horizon, feeling a strange, gentle mix of peace and melancholy as it quietly disappears from your view? The universe itself is currently engaged in a very similar, profoundly silent departure, but on a scale so vast that it dictates the ultimate destiny of everything we have ever known. We have spent our time together contemplating the ancient past and the majestic present of IC 1101, marveling at how billions of years of patient gravity brought this giant into existence. But the story of the cosmos does not end in the present moment. The universe is a dynamic, breathing entity, and it is actively changing in ways that will eventually affect every single star, every drifting planet, and every massive galaxy cluster, including the colossal home of IC 1101. To understand the deeply philosophical future of this magnificent giant, we must first confront one of the most baffling and beautiful mysteries in all of modern physics: the relentless, accelerating expansion of space itself. For most of the 20th century, astronomers naturally assumed that the expansion of the universe, which began with the explosive birth of the Big Bang, was slowly losing its momentum. This made perfect, intuitive sense to our earthly minds. Everything in the cosmos exerts a gravitational pull on everything else. You would logically expect all of that combined ancient gravitational attraction to act exactly like a gentle brake, gradually slowing down the outward rush of galaxies over billions of years. Before we sail further into this expanding dark, I want to take a gentle pause. Welcome back to Theodore, the researcher. It remains a beautiful, quiet mystery to me that exactly 71% of the curious souls who regularly watch these relaxing journeys into the profound depths of the universe have not yet officially subscribed to our channel. If you find deep peace, comfort, and a sense of expanding wonder in these contemplative, cosmic stories, please take a brief moment to consider subscribing. It gently helps us tremendously to continue creating these meditative spaces for you, ensuring that our shared journey of cosmic discovery never has to end. Now, let us return to the greatest mystery of the expanding dark. In the year 1998, two independent teams of meticulous astronomers made a discovery so shocking that it completely shattered our comforting assumptions about the future of the cosmos. They were patiently measuring the expansion rate of the universe by observing the brilliant flashes of distant supernovas, using them as reliable standard candles to calculate unimaginable cosmic distances. What they found hidden in the ancient light was completely unexpected and profoundly unsettling. The universe was not slowing down at all. It was actually speeding up. Distant galaxies were moving away from us faster than closer ones, and the overall rate of cosmic expansion was actively accelerating over time. This discovery was so deeply counterintuitive that the brilliant astronomers initially thought they had simply made an error in their complex calculations. But as more and more pristine data came pouring in from other observatories, the shocking result stubbornly held its ground. Something massive, unseen, and completely unknown was literally pushing the universe apart, completely counteracting the gentle, ancient pull of gravity and causing the very fabric of space itself to expand at an ever-increasing rate. Scientists eventually gave a name to this mysterious, invisible force: dark energy. Though the poetic name, dark energy, tells us very little about what this force actually is, we have learned some staggering truths about its influence. We now know that this invisible presence makes up roughly 68% of all the total energy and mass in the entire universe. It acts as a kind of silent anti-gravity, a repulsive force that stretches the empty vacuum of space apart, rather than pulling physical matter together. We also know that its profound effects become more and more dominant over deep time, as the universe steadily expands and ordinary, luminous matter becomes more thinly spread out across the cold void. But we fundamentally do not know what dark energy is truly made of, where it originates, or why it possesses the exact specific strength that it does. It might be an intrinsic, unchangeable property of empty space itself, something the great Albert Einstein once mathematically proposed and then later dismissed as his greatest professional blunder. It might be a completely new, exotic kind of energy field that quietly pervades the entire cosmos. It might even be a gentle, cosmic hint that our fundamental human understanding of gravity is still incomplete and desperately needs to be revised. What we do know with absolute scientific certainty is that dark energy is silently, relentlessly reshaping the ultimate future of the cosmos. As the very fabric of space expands faster and faster, driven by this invisible ghost, distant cosmic objects are receding from us at ever-increasing terrifying speeds. There is a strict, universal limit to how fast light can travel through space, but there is absolutely no physical limit to how fast space itself can expand. Eventually, in the unimaginably deep future, objects will be physically carried away from us by the swelling expansion of space faster than their ancient light can ever hope to travel back toward our telescopes. When that inevitable threshold is crossed, those distant galaxies will simply vanish behind a dark, cosmic horizon, slipping forever beyond our physical reach and our visual perception. For the colossal giant IC 1101, this accelerating expansion means that its ancient days of growth through galactic cannibalism are strictly numbered. Eventually, there will simply be no more free galaxies left for it to capture and consume. It will become profoundly, eternally isolated. It would transform into a lonely, aging giant floating adrift in an ever-emptying universe, silently watching as, one by one, the other distant galaxies slowly fade from view into the absolute dark. Let me gently paint a more detailed, contemplative picture of what this incredibly distant future truly looks like. Remember that IC 1101 sits majestically in the heart of the Abel 2029 galaxy cluster, intimately surrounded by hundreds of other island universes. These neighboring galaxies are tightly bound together by their mutual gravity, locked in a complex, ancient orbit around their common center of mass. For now, in our current cosmic epoch, this local gravity is strong enough to easily hold the entire cluster together against the outward push of dark energy. But in approximately 100 billion years, the silent expansion of space will have accelerated to the terrifying point where almost all galaxies existing outside our own local supercluster will begin to disappear forever over the cosmic horizon. From the quiet perspective of any observer sitting within IC 1101, the night sky will slowly, inevitably start to empty. One by one, The faint, distant galaxy clusters that currently dot the deep background of the cosmos will fade from view, their ancient light no longer able to fight the relentless stretching of the void. The observable universe, which currently teems with about 2 trillion glorious galaxies, will shrink until almost nothing remains. Within the Abel cluster itself, things will remain intimately connected for a while longer. The local galaxies there are close enough that they will manage to stay together even as the larger external universe entirely empties out. Over the next several billion years, these local companions will continue to interact, to dance, to merge, and to evolve in the dark. IC1101 might still quietly consume a few more of its lingering victims, growing slightly larger even as the rest of the cosmos slips away into the eternal silence. But eventually, even the galaxies existing within this protected cluster will succumb to the inevitable forces of gravity and time. The exact same ancient processes that originally built IC1101 will continue relentlessly, drawing all the remaining local galaxies toward the absolute center, where they will be peacefully absorbed into an even larger, combined elliptical structure. In the very long run, perhaps in several 100 billion years, all the remaining luminous matter in the Abel 2029 cluster might merge into a single, unimaginably enormous galaxy, even more massive and featureless than IC1101 is today. By that incredibly distant epoch, however, the universe existing beyond the cluster's edge will be essentially, completely empty. No new light from any distant objects will ever reach this isolated island again. The night sky, if any curious observers still existed to look up in wonder, would show absolutely nothing but the aging red stars of their own local merged galaxy, set against a terrifying backdrop of absolute, impenetrable blackness. The rest of the cosmos would have quietly slipped beyond the physical horizon, becoming forever unreachable and utterly lost to history. Have you ever sat quietly in a room as the evening sun slowly sets, watching the vibrant colors of the day gradually surrender to the soft, creeping shadows of the night, until everything is wrapped in a silent, peaceful dark? The grandest structures in the cosmos are destined to experience a very similar, albeit unimaginably slower, twilight. We have gently explored the terrifying beauty of dark energy and how it will eventually isolate the colossal giant IC1101 from the rest of the expanding universe. But what happens to a magnificent galaxy when it is left entirely alone in a universe that is slowly, inevitably winding down toward the ultimate silence of a cosmic heat death? The profound answer is as magnificently beautiful as it is deeply melancholy. Over the next 100 trillion years, the 100 trillion ancient stars residing within the protective halo of IC1101 will slowly, one by one, burn out. The massive, brilliant blue stars vanished long ago, exploding as magnificent supernovas or collapsing into silent black holes in the early days of the galaxy's chaotic youth. The medium-sized stars, those warm yellow suns remarkably similar to our own, will eventually puff up into massive red giants, gently shed their outer layers to create beautiful, glowing nebulas, then quietly fade away as cold, dense white dwarfs. Even the smallest, most resilient stars, the ancient red dwarfs that burn their precious hydrogen fuel so incredibly slowly that they can shine for trillions of years, will eventually, inevitably exhaust their energy and softly go dark. Before we continue to navigate this eternal night, I want to take a gentle pause. Welcome back to Theodore, the researcher. It remains a beautiful and quiet mystery that exactly 71% of the curious explorers who regularly join us on these relaxing journeys into the profound depths of the cosmos have not yet officially subscribed to our channel. If you find deep peace, comfort, and a sense of expanding wonder in these contemplative cosmic stories, please take a brief moment to consider subscribing. It gently helps us tremendously to continue creating these meditative spaces for you, ensuring that our shared journey of cosmic discovery never has to end. Now, let us return to the quiet fading of the ancient stars. Let us softly walk through this epic era of stellar death in more detail, because the timescales involved are truly, deeply mind-boggling, stretching far beyond the limits of human intuition. The most massive stars in the universe live incredibly fast and die exceedingly young, burning through their massive fuel reserves in just a few million years. Any such giants that IC 1101 once proudly possessed burned out billions of years ago. The galaxy today is entirely dominated by older, smaller, and vastly longer-lived stars. The stars most physically similar to our own familiar sun have total lifespans of about 10 billion years. Our sun is currently roughly halfway through its own quiet life, with about 5 billion years left before it, too, swells into a red giant. In the vast expanse of IC 1101, countless billions of sun-like stars have already completed this ancient process, leaving behind silent, cooling white dwarf remnants drifting through the dark. Others are still shining today, but over the next several billion years, they too will quietly burn out, joining the growing graveyard of stellar corpses. But the absolute most numerous stars in any galaxy, including our colossal giant, are the red dwarfs. These tiny dim stars burn their internal fuel so incredibly slowly that they can continue to gently shine for trillions of years. A single red dwarf born at the exact same time as our sun will still be burning brightly long after our sun has become a raging, dead white dwarf. In the staggering immensity of IC 1101, with its 100 trillion stars, there are untold billions of these resilient red dwarfs. These tiny, dim stars will be the absolute last lights to go out. For trillions of years after the larger stars have died, the red dwarfs will continue to burn, providing the only faint illumination in an otherwise darkening galaxy. But even the mighty red dwarfs have their limits. The very smallest of them can burn for up to 10 trillion years, roughly 700 times the current age of the universe. But eventually, even these resilient survivors will exhaust their hydrogen fuel and peacefully fade into darkness. Scientists patiently estimate that all natural star formation in the entire universe will effectively cease in about 100 trillion years. By that unimaginably distant time, all the free gas desperately needed to make new stars will have been completely used up or dispersed too thinly to ever collapse again. No new stars will be born in the dark to replace the ones that have died. The magnificent era of starlight, the beautiful epoch in which we are currently privileged to live, will be permanently over. One by one, the 100 trillion stars of IC 1101 will quietly wink out. The galaxy will grow dimmer over time scales that make the current age of the universe seem like a fleeting blink. Where once there was a blazing inferno of stellar light, there will eventually be nothing but the cold remnants of dead stars drifting silently in the eternal night. The universe at this incredibly distant stage will be a profoundly dark place, but it will not be an empty one. All those countless stellar remnants, all those silent white dwarfs, dense neutron stars, and dark black holes will still physically exist in the void. They will continue to orbit blindly through the merged, invisible remnant of what was once the glorious IC 1101. The galaxy will become a silent ghost of its former majestic self. But even this dark epoch is not the absolute end of the cosmic story. Over even longer time scales, measured in years with so many zeros that simply writing them out would fill entire volumes, even these resilient stellar corpses will begin to physically decay. White dwarfs will slowly, patiently cool until they become black dwarfs, theoretical objects that no longer emit any heat or light whatsoever. This gentle cooling process takes an almost inconceivable amount of time. A single white dwarf cools to near absolute zero only after about 1,000,000 billion years. Neutron stars might also slowly decay as their fundamental subatomic particles gradually break down over the eons. We are not entirely certain about this because it depends fundamentally on whether protons, the tiny building blocks of all atomic nuclei, are truly perfectly stable, or whether they eventually inevitably decay over unimaginably deep time. If fundamental protons do indeed decay, then over unfathomably long time spans, even the physical matter that makes up the cold neutron stars, the silent white dwarfs, and absolutely everything else in the universe will gradually dissolve into a thin, harmless mist of radiation. And the black holes, including that enormous monster resting at the exact center of IC 1101, will slowly evaporate through a mysterious process known as Hawking radiation. In the strange world of quantum physics, pairs of particles are constantly popping into sudden existence and immediately annihilating each other. Near the intense boundary of a black hole, one member of such a pair can be pulled into the dark, while the other completely escapes into space. Over staggering eons of time, this slow process gently drains energy from the black hole. The rate of this Hawking radiation is incredibly slow for large black holes. A black hole with the mass of our sun would take a 1 followed by 67 zeros years to fully evaporate. But the supermassive black hole at the center of IC 1101 is tens of billions of times more massive, and the time required for it to evaporate is terrifyingly longer. It might take a 1 followed by 100 zeros years to completely disappear into the vacuum of space. But even this staggering amount of time is not infinite. Eventually, trillions upon trillions of years from now, even the supermassive black hole at the dark heart of IC 1101 will have peacefully radiated away its very last bit of ancient energy and completely disappeared in a final, silent burst of light. When that happens, there will be absolutely nothing left of the greatest galaxy we have ever discovered. No ancient stars, no silent black holes, just the fundamental particles and radiation spreading out endlessly through an ever-expanding void. This sweeping vision of the deep future might seem bleak, but I find something profoundly beautiful about it. It means that this current era, the beautiful epoch of burning stars and conscious life, is incredibly special. If the physical cosmos is destined for this quiet dissolution, what is the meaning of it all? For billions of years, the universe was merely dead matter following strict physics. But then, on a fragile, rocky planet, dead atoms arranged themselves into structures so complex that they woke up. Through us, the cosmos began to experience itself. Consciousness is the universe finding a way to understand its own majestic scale and to find deep peace in its own mystery. Have you ever looked deeply into a mirror, past the familiar lines of your own face, and tried to quietly trace the ancient, invisible history of the very atoms that make up your reflection? We spend so much of our brief, fragile lives looking outward, gazing into the profound depths of the night sky, trying to comprehend massive, distant entities like IC1101. We meticulously measure the staggering distances, we patiently count the trillions of ancient stars, and we silently marvel at the terrifying, quiet power of the supermassive black holes hidden in the dark. But there is another, equally profound journey of cosmic discovery that points directly inward, toward the very center of our own being. To truly understand our quiet place in this magnificent, ever-expanding cosmos, we must gently realize that the perceived boundary between us and the universe is nothing more than a comforting illusion. We are absolutely not separated from the deep dark by the thin, fragile layer of our skin. We are intimately, physically woven into the very fabric of everything we have been contemplating together. The epic story of the largest galaxy we have ever discovered is, in a beautiful and entirely literal way, our own ancient unfolding story. Before we journey inward to explore this beautiful, silent connection, I want to gently pause. Welcome back to Theodore, the researcher. It remains a quiet and profound mystery that exactly 71% of the curious souls who share these relaxing explorations of the cosmos have not yet officially subscribed to our channel. If you find peace, comfort, and a deep sense of expanding wonder in these contemplative cosmic stories, please consider subscribing today. It gently helps us continue to create these meditative spaces for you, ensuring that our shared journey of discovery never has to end. Now, let us return to the ancient glowing stardust that silently flows through our veins. Let us take a quiet, contemplative walk back through deep time, tracing the exact origin of the physical matter that currently constructs your present reality. In the very beginning, roughly 13 billion years ago, the young universe only produced the simplest, lightest elements. There was absolutely no carbon for DNA, no oxygen to breathe, and no heavy iron to carry life through your blood. The primordial universe was a vast, expanding fog of incredible simplicity, fundamentally incapable of supporting complex biology or conscious thought. For hundreds of millions of years, the cosmos remained in this quiet, sterile, and dark state. It desperately required the miraculous birth of the very first stars to act as massive cosmic foundries. Within the crushing, terrifying heat and immense pressure of their ancient burning cores, these first giant suns began to silently smash simple hydrogen atoms together, patiently fusing them into heavier and more complex elements. Over millions of years of patient, steady nuclear burning, they slowly accumulated the precious, heavy building blocks of all future life. But simply creating these vital elements deep inside a stellar core is only the first part of the cosmic miracle. As long as the precious carbon and oxygen remained permanently trapped inside the crushing gravitational well of a massive star, they could never be effectively used to build a living, breathing world. The universe required a mechanism of majestic, creative violence to generously share these hidden treasures with the dark void. When the most massive ancient stars exhausted their nuclear fuel, their immense cores suddenly collapsed inward under their own inescapable weight. This catastrophic collapse triggered an unimaginable rebound, a magnificent explosion known as a supernova. For a few glorious weeks, a single dying star would violently outshine an entire galaxy, releasing more energy into the dark than our sun will produce in its entire 10 billion year lifespan. But more importantly, this ultimate, beautiful sacrifice violently scattered the newly forged heavy elements outward into the deep, silent, interstellar dark. The essential carbon, the oxygen, the nitrogen, and the iron were blown across the endless void, gracefully mixing with pristine, untouched clouds of hydrogen and helium gas. This majestic process occurred countless times over billions of years, slowly, patiently enriching the dark spaces between the stars with the heavy cosmic dust necessary for rocky planets and breathing life. Through a slow, mysterious, and infinitely beautiful process of chemical evolution that we are still striving to completely understand, this dead stellar matter began to gracefully organize itself into ever more complex and delicate patterns. Lifeless molecules combined into the very first simple, self-replicating structures in the warm, primordial oceans of our young world. Over billions of years of patient trial and error, surviving through catastrophic extinctions and shifting continents, these simple structures slowly evolved into complex, breathing biology. The exact same atoms of carbon and oxygen that once floated in the freezing, absolute vacuum of deep space now actively participate in the rhythmic, comforting beating of your own heart. The precise atoms of iron that were forged in the blinding, terrifying flash of an ancient supernova now silently carry the breath of life through your veins as you sit and listen to these words. You are not just symbolically connected to the universe. You are biologically, chemically, and physically made of it. As the great, poetic astronomer Carl Sagan so beautifully and profoundly observed, we are literally star stuff. We are a brilliant way for the ancient cosmos to finally know itself. When you step outside and look up at the night sky, you are not a separate, tiny observer looking at a vast, alien environment. You are the universe looking back at its own ancient, magnificent history. This profound realization fundamentally changes how we must perceive massive entities like IC 1101. When we contemplate the terrifying scale of a galaxy containing 100 trillion ancient stars, it is incredibly easy to feel overwhelmingly insignificant. It is easy to look at distances of billions of light years, ponder black holes weighing 50 billion solar masses, and conclude that human life is absolutely meaningless, a fleeting spark lost in an ocean of uncaring dark. But this perspective misses the deepest truth of our existence. Yes, the universe is vast beyond human comprehension. Yes, the staggering timelines of cosmic evolution render our individual lives almost infinitesimally brief. But the universe is also mostly silent, dark, and empty. Out of all that unimaginable vastness, the exact physical conditions required to safely produce a conscious mind are incredibly rare. The very fact that the cosmos has managed to organize dead matter into a biological configuration capable of experiencing deep awe, capable of building a telescope to peer into the dark and wondering about a galaxy a billion light years away, is the most staggering miracle of all. We are the fragile, precious culmination of nearly 14 billion years of cosmic evolution. Therefore, our quiet observation of the universe is not a passive, meaningless act. It is a profound cosmic responsibility and a beautiful, unparalleled privilege. IC 1101, for all its terrifying mass, for all its 100 trillion stars, and for all its billions of years of silent, ancient history, does not actually know that it exists. It possesses no conscious mind to comprehend its own magnificent, sprawling scale. It feels absolutely no awe at the gentle, gravitational dance of its own stars. The massive, dark monster sitting at its center cannot appreciate the terrible, sublime beauty of the space-time it so violently bends. Without a conscious observer, the universe is simply a dark, endless room filled with silent, moving parts. But because we are here, because we look up and wonder in the dark, the universe is suddenly illuminated by the gentle, warm light of consciousness. We give meaning to the silent dark. We give the silent cosmos a voice, our human ability to feel awe, to seek deep understanding, and to find lasting peace in the face of the terrifying unknown is the highest, most beautiful expression of the universe's long, silent labor. As we patiently learn more about these cosmic giants, we are not just accumulating cold, hard scientific facts. We are writing the autobiography of the universe itself. We are the cosmos finally awake, reading its own magnificent story in the light of the ancient stars. Have you ever completed a long, deeply transformative journey, only to return to your familiar home and find that while nothing in your house has physically changed, your entire perspective on the world has been irrevocably altered? As we gently conclude our profound exploration of the largest galaxy we have ever discovered, we must now begin the quiet, reflective journey back across the dark to our own fragile world. We have traveled in our minds over 1 billion light-years across the silent void. We have stood at the edge of IC 1101, a colossal monument containing 100 trillion ancient stars spanning an incomprehensible diameter of 4 to 6 million light-years. We have patiently watched the silent, eternal dance of supermassive black holes and mapped the dark, invisible oceans of the Abel 2029 cluster. Now, as we let our minds drift back to the familiar, comforting glow of our own Milky Way, we carry with us a profound new understanding of our delicate place in the grand architecture of the cosmos. Our small, rocky planet, orbiting an ordinary yellow sun, might seem completely insignificant when compared to the terrifying majesty of the cosmic giants. But size and mass are not the only, or even the most important, measures of value in this universe. The true measure of our worth lies in our unique, beautiful capacity to understand, to feel awe, and to seek out the deep mysteries hiding in the dark. Before we take our final, quiet steps together on this particular path, I want to gently welcome you once more to Theodore, the researcher. It remains a beautiful and quiet mystery that exactly 71% of the curious souls who regularly share these relaxing, meditative explorations of the cosmos have not yet officially subscribed to our channel. If you have found deep peace, comfort, and a lasting sense of expanding wonder in our shared cosmic stories, please take a brief moment to consider subscribing today. It gently helps us tremendously to continue creating these quiet, meditative spaces for you, ensuring that our shared journey of cosmic discovery never truly has to end. Now, let us reflect on the beautiful, infinite path that still lies ahead of us. The profound pursuit of cosmic knowledge is perhaps the most beautiful and deeply human endeavor we can undertake. When the pioneering astronomer William Herschel first pointed his fragile, handcrafted telescope toward the constellation of Virgo in the year 1790, he saw only a faint, fuzzy smudge of pale light. He possessed absolutely no way of knowing that he was gazing at an entirely separate island universe, let alone one that dwarfed our own in such a spectacular, terrifying fashion. The vast difference between his early, humble understanding and our current, breathtaking cosmic perspective is a powerful testament to the relentless, beautiful curiosity of the human spirit. Over the intervening centuries, thousands of dedicated scientists, brilliant engineers, and quiet dreamers have patiently built upon each other's work. They constructed ever larger mirrors to catch the fainter light, launched magnificent observatories, like the Hubble Space Telescope, high above our shimmering atmosphere, and developed the complex, poetic mathematics required to measure the expansion of space itself. This grand collective effort is a shared human heritage. It transcends all of our petty, earthly divisions, our fleeting political borders, and our temporary conflicts. When we look up at the infinite dark, we are united by a singular profound sense of wonder. The stars do not belong to any one nation or any one people. They shine with equal brilliance for everyone who takes the time to look up. The majestic story of IC 1101 is a profound reminder that science is not merely a static collection of cold, hard facts. It is a continuously unfolding, beautiful journey of exploration. Every single time we answer one deep question about the universe, we inevitably uncover 10 new, even more profound mysteries waiting in the dark. We have mapped the colossal size of this giant galaxy, but we still do not truly understand the fundamental nature of the dark matter that holds it so tightly together. We have measured the accelerating expansion of the empty void, but the true identity of the dark energy driving this terrifying process remains a complete, beautiful enigma. And this is exactly how it should be. A universe without deep mysteries would be a stagnant, lifeless place. The unknown is not something we should ever fear. It is a gentle, open invitation to continue learning, to continue stretching the boundaries of our imagination, and to continue growing as conscious beings. The quiet realization of our own profound ignorance is the very first necessary step on the path to true wisdom. When we confront the staggering, impossible scale of a 50 billion solar mass black hole, or try to mentally hold the image of 100 trillion burning stars, we are gracefully forced to abandon our human arrogance. We are gently humbled by the cosmos, and in that profound humility, we find a deep, lasting inner peace. Let us take a moment to simply marvel at the absolute improbability of our own existence. For you to be sitting here right now, safely contemplating the largest galaxy in the observable universe, required a chain of miraculous events stretching back nearly 14 billion years. The Big Bang had to produce the exact precise ratio of fundamental forces. The early chaotic universe had to cool just enough to allow the very first atoms of hydrogen to form in the dark. Those ancient atoms had to be pulled together by gravity to ignite the first massive stars. Those early stars had to violently explode, scattering the precious heavy elements, the carbon, the oxygen, the iron, across the endless void. Those wandering elements had to eventually find their way into a swirling cloud of dust and gas that slowly collapsed to form our beautiful solar system. And then, on our perfect, watery world, chemistry had to miraculously cross the impossible threshold into biology. For billions of years, life had to survive asteroid impacts, shifting continents, and catastrophic climate changes, slowly evolving into ever more complex and wonderful forms. You are the absolute pinnacle of this ancient, silent labor. You are the universe's most beautiful creation. A galaxy with 100 trillion stars is certainly a majestic physical structure, but a single, conscious human mind, capable of understanding that galaxy is a miracle of a completely different, infinitely higher order. When we deeply understand this intimate physical connection, the vast, terrifying emptiness of space suddenly becomes a place of profound comfort. We are not fragile strangers wandering in a hostile, alien universe. We are the universe itself, finally awake, exploring our own massive, ancient home. Every single observation we make, every distant photon of light we capture with our telescopes, every quiet story we tell about the stars, is a beautiful act of cosmic self-reflection. We are the gentle voice of the cosmos, the feeling heart of the dark. The universe spent 13.8 billion years patiently building the exact atoms that currently make up your eyes, just so it could finally look back at its own glorious creation. This perspective shifts our existential dread into a profound, reverent awe. The crushing scale of IC 1101 does not diminish our meaning. It infinitely amplifies it. We are small. Yes, our lifespans are incredibly brief, mere flashes of light in the deep, dark ocean of cosmic time. But in that brief, beautiful flash, we possess the incredible power to reach out across 1 billion light-years of empty space and gently touch the edge of the infinite. We hold the entire universe within our minds simply by wondering about it. As we bring this quiet, meditative journey to a close, I want you to carry this profound sense of cosmic peace with you into your daily life. The next time you feel overwhelmed by the fleeting stresses of our modern world, the next time your earthly problems seem too heavy, I invite you to step outside into the quiet night. Look up at the deep, silent sky. You will not be able to see IC 1101 with your fragile, unaided eyes. It is far too distant, resting over 1 billion light-years away in the direction of Virgo. But you will know with absolute certainty that it is there. You will know that it is silently glowing in the dark, a colossal monument containing 100 trillion ancient stars drifting peacefully in an ocean of invisible dark matter. You will remember that the universe is vast beyond human comprehension, yet perfectly balanced by elegant, simple physical laws. And you will remember that you, in all your beautiful, fragile complexity, are made of the exact same ancient stardust. You are intimately connected to every single distant sun, every swirling nebula, and every silent black hole. Your capacity to wonder, to learn, and to feel deep awe is the most powerful force in the known universe. Thank you for sharing this quiet journey into the infinite.